Assalamu alaikum dear students. We discussed the injective function, the bijective function, the surjective function. Now today we are going to discuss the same, that is how to check whether the function is bijective or not. That is exercise question this exercise 2.1. Now the question first is, a function is defined from OR star to OR star, that is its domain, this domain as well as codomain is same set, by f of x equals to 1 upon x. F of x equals to 1 upon x. We have to check it is bijectivity, that is we have to check whether this is 1 1 or onto or both. Here this OR star is the set of non-zero real numbers. Now is the result true if we change its domain by n? That is, we have to check the same function if we consider n to be its domain. Now firstly, if we consider function from OR star to OR star, that is we consider its domain as OR star. Then for 1 1 function, that is injective function, let x1 x2 be any 2 points. We don't know whether they are equal or not from the domain, means OR star, such that their images are same, that is f of x1 equals to f of x2. But f of x1 is defined as 1 upon x1, f of x2 equals to 1 upon x2, because f of x is defined as f of x equals to 1 upon x, which implies that by cross multiplication x1 equals to x2. Hence, if we have two same images, these two same images are actually the images of the same points, means that x1 equals to x2. Hence different, we can say that different elements of OR star have the different images, which implies that the function is 1 1 function. Now for onto function, means surjective function, now we have to check that each and every point of second OR is actually in the image point. Now let y belongs to OR star, means this is the this point from the codomain, means second OR, be arbitrarily element or the point of codomain. Now if f is onto, we assume here that f is onto, this means that there should exist at least one x in the first OR, such that f of x equals to y. But f of x is defined as 1 upon x. Here we know the y, we have to check whether this x belongs to OR star or not, which implies that by cross multiplication x equals to 1 upon x. Now here y is real, 1 upon y is defined for all real numbers except y not equals to 0, because y is not equals to 0, because this OR star is the set of non-zero real numbers. So this means that when y is real, implies that 1 y is also real, hence x is real. Now when x is real, so it is non-zero real, which implies that, and defined, which implies that there exists x such that there exists x which is of the form of 1 by y, because x equals to 1 by y, such that f of 1 by y equals to y. So this is onto function. Hence this is bijective function, because bijective means 1 1 onto function. Now if we consider the same function from n to OR star, where n is the set of natural numbers, then firstly we will check its bijectivity, this injectivity. Let x1 x2 belongs to n, such that their images are same, but f of x1 is defined as 1 by x1 and f of x2 is 1 by x2, which implies that x1 equals to x2. Hence f of x1 equals to x2 implies that x1 equals to x2, which implies that if we change its domain from OR star to n, the function is still injective function. Now for onto, by the same procedure, let y belongs to OR star, means codomain element. Now we have to prove that this is the image of some or the other elements of some elements from this n. Now if this is onto, which implies that there exists x belongs to first n, such that f of x equals to y, which implies that here we know the y, because this is the element we choose from this OR star, and this is fixed, which implies that x equals to 1 by y. Now here y is real, non-zero real, so this means that 1 by y is defined, and x belongs to this n, so this means that x should be natural number. Now if y is 2, because y belongs to this, y equals to 2 belongs to r star, implies that x is equals to 1 upon 2, which is not natural. So this means that there exists at least one point in this r star, that is 2, which is not mapped to any element of this n, hence this is not onto. So this means that our supposition is wrong, which implies that the function is not onto. So we can say that if we change its domain from r star to n, it changes its behavior, that is from r star to r star, the function is on this bijective function, while as if we change its domain from from r star to n, it is only 1 but not onto. Now if we consider another function f from n to n defined by f of x equals to x square, we have to check its bijectivity, means we have to check that this function is 1 or onto. Let x1 x2 belongs to n for 1 such that their images are same, means f of x1 equals to f of x2, implies that x1 square equals to x2 square, or x1 square minus x2 square equals to 0. Now x1 minus x2 into x1 plus x2 equals to 0, because a square minus b square is a minus b into a plus b. Here we have two numbers, x1 minus x2 and x1 plus x2. Their product is 0. This means that either 1 is 0 or x plus 2 equals to x1 plus x2 equals to 0. From first, x1 equals to x2 or x1 equals to minus x2 from second. So we have here two conditions, x1 equals to x2 and x1 equals to minus x2. But here we have the n set of naturals which are positive, so this means that second condition is rejected, because here x1 equals to minus x2. That is, from this we only get x1 equals to x2. This means that for different images we have for different elements we have different images, because f of x1 equals to f of x2 implies x1 equals to x2, so the function is 1 function. Now suppose the function is onto, which implies that there exists y belongs to n. Now for y belongs to second n, means codomain n, there exists x belongs to first, such that f of x equals to y, implies that x square equals to y, implies that x equals to plus minus root y. Here we again reject root minus root y, because x is always positive. So this means that from this, x is of the form of root y. For y, x is of the form of root y. But if we consider y to be 2, which implies that x equals to root 2, but x equals to root 2 is irrational. So this means that for y equals to 2, there exists actually irrational number which is mapped through this function. But x equals to root 2 does not belongs to this natural. So this means that our supposition is wrong, that function is onto, hence the function is not onto. Now if we consider the same function from z to z defined by f of x equals to x square, then clearly f of 1 equals to 1 square, that is 1, f of minus 1 equals to minus 1 square, that is again 1. So this means that here we have two different elements, 1 and minus 1, which are mapped or related to same element. So this means that it is not 1 function. Now if we consider the same function from for onto, that is from z to z defined by f of x equals to x square, still from the still for same domain and codomain, we get for 2 actually is 2 is the image, like here we proved that actually 2 is the image of root 2, but root 2 does not belongs to n in this function. But if we consider here the same, so this means that there exists root 2 belongs to first, such that which is mapped with the 2, which is not which is not the true statement, because root 2 is neither natural nor this integer. So this means that this function, if we consider the same function z from z to z defined by f of x equals to x square, this function is neither 1 1 nor onto. So thank you.